Hello, 8th graders. It's Mrs. Thompson. We're back in 4.6 looking at example 4 today, and now we're going to make an application and use an application to show you how slope-intercept form works in real life. And so this is a consumer application. A consumer is just somebody who spends money. We're consuming a particular thing. It could be food. It could be just about anything. In this particular case, we're renting a van. So a moving company charges $30 plus 50 cents per mile. The cost as a function of the number of miles driven is shown in the graph. And so you can see our graph, and I want you to kind of take a look at this graph and notice the y-axis is showing total cost in dollars. So it looks like they're going by tens on the y-axis, and the x-axis is distance driven in miles. Looks like they're going in increments of 5 is what it looks like. So they're skipping every other one. So it may look like they're going by tens on the x-axis. They're really not. This line in between is actually, there's the 5 right there. So they're going by 5s. Now, our first objective, letter A, we're supposed to write an equation that represents the cost as a function of the number of miles. Now, there's a couple of things. I want to deconstruct how they've written this. We know what our objective is. We know that we're going to write an equation, okay? I'm really surprised that they didn't say in slope-intercept form. Usually they're real detailed about stuff like that. But I think the information given lends itself to slope-intercept form. So I'm going to get to that in just a few minutes. Well, the words I want to focus on right now, cost as a function of the number of miles. We know what a function is, and they're telling us, the way that they have it worded, they are telling us some important information. Cost, remember, is our dependent variable. Remember, a long time ago, we studied what depends on what. And in this particular case, the total cost of the moving van really depends on how many miles that moving van goes. So right away, we know that cost is going to be equal to the number of miles driven. That's going to definitely be an affecting force, okay? That's going to be a pretty important part. So, cost is going to be our dependent variable, and number of miles is going to be our independent variable. Okay, so we have some basics here. The important thing is, do you know what is on the left that should be by itself and what goes on the right that is going to affect the cost? Miles affects the cost. Now, I need you to go back to the very beginning when I first read the problem to you, because some important information is there. And now's the time we're going to talk about it. Why does this information lend itself to being slope-intercept form? Well, let's talk about that. First thing I want to talk about is this $30. That is a flat rate. It's not $30 per hour. It's a one-time fee. I'm going to write that down for you. One-time fee of $30, okay? Now, that's a constant number that doesn't have a variable attached to it because it does not recur. It occurs one time and only one time, and thus that's the one-time fee. You know what, guys? That is always going to be your y-intercept, okay? So even if you walk into the rental place and you say, hey, I want a van, I want to rent a van, they're going to say, that will be $30 right off the top. Before you even get in the van, before you drive the first mile, you have to pay $30. So that's your flat rate, one-time fee. That will always be your y-intercept, and in our equation, that's going to be B. That's true for every flat rate, one-time fees, numbers that don't have a variable attached to it. Anticipate that number being your y-intercept, okay? Then they give us the plus, so we know we're adding to it. The cost is going to increase or be added to because we're going to be charged 50 cents every mile that's driven. So the way that I know where to position that in my equation is I look for that rate. Remember we learned in a couple sections ago, rate of change is slope. Well, this is something per something. It could be miles per hour, 50 cents per mile, inches per second. If you have some sort of rate where you see the word per, P-E-R, you know that has to be your slope. So this is going to end up being your slope because it's affected by the number of miles driven. The more miles I drive, the more money I pay. Okay? So the 50 cents is going to increase every mile that's driven. So that's how I know it's the slope. So what we want to do is we want to plug in to this basic equation, y equals mx plus b, and we know cost is affected by number of miles. So I've got cost on the y side, that's where it should be, it's my dependent variable, and number of miles should be on the right because that's where my independent variable goes. So as I write this equation, this is how it's going to turn out. My slope, my rate, is 50 cents per mile. So there's that 50 cents, 0.50 in front of the x, because x is number of miles, plus my $30 flat rate. That's what I'm going to pay before I even drive the very first mile in that van. Okay? If you have questions about how to write the equation, let's talk about this more in class tomorrow. All right, moving on to B, we want to identify the slope and the y-intercept and describe their meanings. Now, if you're writing an equation, you should somewhat know which one's the slope and which one's the y-intercept anyway. So we'll just say slope is 0.50 and the y-intercept is 30. So there we've identified it. The hardest part of this is we're going to have to tell what it means, and perhaps the graph would be the best way to help in this situation. So let's start with the slope. Remember, slope is rise over run, okay? And the rise, remember, is total cost over distance driven, which our units are miles. So basically cost per mile. So that slope is how much money it's going to cost me as the consumer to drive every single mile. Okay? Hopefully that makes sense. If it doesn't, rewind me, listen again, and we've already practiced this a little bit, so hopefully this is kind of you're locking in on this. If you have questions, let's talk about it in class tomorrow. All right, now let's get to the y-intercept. Now the y-intercept, remember, is the point 0, 30. So if you look at your x-axis, 0 on the x-axis means before we've even driven any miles at all. At mile 0, the total cost is $30. That's the interpretation. That's how you look at that number and tell what it means. Okay, we've had some experience with letter B with this particular part of this example, so hopefully this is not altogether foreign to you. Now letter C, now we're going to take our equation and we're going to find the cost of driving 150 miles. 150 miles is number of miles. That's what we're going to plug in for x. And we're going to figure out if I drive 150 miles, how much am I going to pay this moving company? So let's plug it in. So we've got 0.50 times 150 plus 30. Now remember, 50 cents is half a dollar, right? So we're going to take half of 150. So in your calculator, type in 0.50 times 150. And that's, of course, 75. And then add 75 and 30 together. Still got to pay that $30 one-time fee. We owe the moving company a total of $105 just for driving 150 miles. So I'm going to pay that flat rate fee before I even drive it anywhere off the lot even, and then I'm going to add to it 50 cents for every mile driven. All right, guys, that's it for example 4. Please write your questions down and bring them to class tomorrow.